Good morning. It is Tuesday, March the 24th, and today we are actually going to review what we did on Thursday, March the 12th. The trig identities, you should already have these written in your notebook, and you already have the worksheet for this. However, if you are absent, I will also scan it and post a copy of it. But these are our basic trig identities we'll be using: the reciprocal identities, the quotient identities, and the Pythagorean identities. Remember, they will give you a trig ratio and ask you to find another trig ratio. But right up here in red, this is the key issue. Do not use right triangles to solve in this unit. Everything in this unit will be solved using the trig identities. They're kind of like puzzles. You've got to figure out how to get from one identity to the other identity. Sometimes it might just be one step. Sometimes it could require 2 or even 3 steps. You want to look at what they give you. They've given me the secant, and they want me to find the tangent. So look at your identities and figure out, is there an identity that relates secant and tangent together? And there is the Pythagorean identity, and that Pythagorean identity is 1 plus tangent squared equals secant squared. So I'm going to use that identity. 1 plus tangent squared is equal to secant squared. And then I'm going to substitute in the secant. 1 plus tangent squared equals 3 squared. And then just continue to solve. I'm going to subtract the 1 over. I have tangent squared theta equals 8. And then I'm going to take the square root of both sides. Square root of tangent squared will give me just tangent, which is what I'm looking for. And the square root of 8 will give me plus or minus 2 radical 2. Remember, 8 is the same thing as 4 times 2. Sometimes they will say just first quadrant angles, and then you don't have to worry about the plus or minus. But if not, use your plus or minus. All right, this second one here, if cotangent equals 1/5, find sine. Now, you cannot use that the cotangent is the cosine over the sine, or the tangent is the sine over the cosine, because those could have been reduced. So you need to use something other than your quotient identities. I am going to use cotangent to find my cosecant with the Pythagorean identities. And then I'm going to use the reciprocal identities. If I know cosecant, I'm going to find sine. That's going to look like 1 plus cotangent squared is equal to cosecant squared. Got my little angle variable. 1 plus 1/5 squared equals cosecant squared. 1 plus 1 squared is 1, 5 squared is 25. And then, I need to have a common denominator, so I'm going to make this 1 25 over 25. So 26 over 25 is equal to the cosecant squared. Since I want just the cosecant, I'm going to take the square root. So that'll give me plus or minus radical 26 all over 5 equals the cosecant. Square root of 26, it won't simplify at all, so it's going to stay under a radical. And then square root of 25 is 5. So now if the cosecant is equal to that, plus or minus radical 26 over 5, my sine is going to be 1 over the cosecant. Or the sine is the reciprocal of the cosecant, so you can just flip it. then what happens right here is you rationalize the denominator. I would end up with a final answer of 5 times the square root of 26 all over 26. The first one only required us one step. This problem required 2 steps. Again, sometimes they'll require 1 step, sometimes 2, sometimes perhaps even 3 steps. They're kind of like puzzles you have to figure out. How can I get from point A to point B? All right here I've got a cosecant. If cosecant equals 2, find cosine. Well, the first thing that pops in my head is cosecant can give me sine from my reciprocal identities, and then sine can give me cosine from my Pythagorean identities. Let's see, if cosecant equals 2, sine is equal to 1 over the cosecant. So sine is equal to 1 over 2. And then I have the Pythagorean identity, sine squared theta plus cosine squared theta equals 1. So 1/2 squared plus cosine squared. And I'm going to simplify this equation. 1/2 squared, numerator is 1, denominator is 4. 1/4 plus cosine squared. This is 1, which I'm going to go ahead and have a common denominator of 4 over 4. Subtract 1 over 4. And I get cosine squared theta equals 3/4. Take the square root. I would have that the cosine is equal to plus or minus 3 won't simplify, so it'll stay radical 3. Square root of 4 will be 2. So the cosine would be equivalent to positive or negative radical 3 all over 2. Now, I know all 3 of these are review, and I honestly do not remember who was in class that Thursday and who was not. But like I said, I will scan and post the worksheet if you did not get it in class that Thursday. Now, something else we're going to look at today is simplifying. This we did not look at, so this is considered new. Simplify using trig identities. Now, these 2 hints will serve you well for the rest of the week into next week. When we are trying to simplify or verify, which we'll be working on the next 2 days, you're going to try to rewrite things in terms of sines or cosines. And if you see pluses or minuses, think about your Pythagorean identities. It says use Pythagorean identities if you have a trig squared added or subtracted with one or another trig squared. For example, we wrote down that sine squared theta plus cosine squared theta equals 1. However, that also means that, sine squared theta would be the same thing as 1 minus cosine squared theta. You can subtract that cosine over. Or cosine squared theta would be the same as 1 minus sine squared theta. So all of those Pythagorean identities can move around, so keep an eye out for those. Again, the 2 tricks are to rewrite in terms of sines and cosines, or if you see pluses and minuses, consider your Pythagorean identities. This first example here, simplify cosecant times sine. And I will post these notes also. Cosecant is, if I want to convert that to sine, cosecant is the same thing as 1 over sine. Times sine, which if you want to put a 1 under there, you can. Well, these 2 sines just cancel each other out, and I'm left with just 1. When you simplify, you should be left with 1 single trig ratio, or perhaps sometimes you can get 1 as an answer. So I switched cosecant to 1 over sine. The sine in the numerator there and the sine in the denominator canceled out, and I'm left with 1. All right, the second example, tangent and cosine. Well, tangent is the same thing as sine over cosine times cosine. We'll put a 1 underneath there. And then just like on that last problem, these two cosines can cancel out, and my answer would be sine. I use the quotient identities to switch tangent to sine over cosine. Those cosines canceled, and I'm left with sine. So these two are good examples of where you try to switch things into terms of sines and cosines. Down here on number 3, where you see this minus, remember I said if you see pluses or minuses, think about your Pythagorean identities. And right up here, where I rearranged this, you know, we saw that sine squared is 1 minus cosine squared, and cosine squared is 1 minus sine squared. So this on number 3, this 1 minus sine squared, is the exact same thing as cosine squared. So I'm going to switch that 1 minus sine squared to cosine squared. This secant, I'm going to switch to 1 over cosine. And then again, now we have things that will reduce. This cosine in the denominator will reduce with this cosine squared and leave me with a single cosine, or a cosine to the first. Cosine times 1 is going to be cosine x. This last one, number 4. In the numerator, it looks like I need to switch to sines and cosines. So I'm going to rewrite tangent as sine x over cosine x. And rewrite cosecant x as 1 over sine x. And then remember from our Pythagorean identities, 1 plus tangent squared is the same thing as secant squared. All right, so I'm going to simplify a little bit in the numerator. These signs can cancel, and I have 1 over cosine x. Secant squared, I'm going to rewrite as its reciprocal identity. Switch to sines and cosines. Secant squared would be 1 over cosine squared x. So now it's like I have a fraction divided by a fraction, so I'm going to keep the numerator. I'm going to change it to multiplication, and I'm going to flip the denominator. I can reduce. And I'm left with cosine x. Okay, so the review material was when they give you one ratio and you find a different ratio. These 4 problems would be new material. You are just simplifying down to a 1 or a single trig ratio. All right, I hope you have a great Tuesday. If you have any questions, please feel free to send me a text through Remind or an email. I will scan the worksheet if you happen to be absent that day. Have a great Tuesday.